Hello class, I hope this lecture finds you doing well. Today's topic we will be going over chemical reactions. So, first I wanted to go through our objectives. By the end of this lecture I want you to be able to list all 5 types of chemical reactions and be able to describe each type of chemical reaction. So, not only just the names but also understanding what each one is. So, as always I like to start with a video. I always think someone else showing it and explaining it is a good way to start to get our brains thinking about it, and then I like to go in and list out what we have. So this video is linked in our Google Classroom as always. So we have a few videos today, so I hope they're labeled easily and you're able to find them and understand them easily. So our types of chemical reactions is what we're going to start with, but first I want to define what a chemical reaction is. A chemical reaction is a process of elements rearranging to form a new product. So, by rearranging our different elements or different compounds, we can get a new product out of it. This is all of what chemistry is. So, it's a very basic definition, and we have 5 different types. We have synthesis, decomposition, combustion, single displacement, and double displacement. So we're going to spend the rest of our lecture going into depth on each one of these types. Our first type is synthesis reaction. So this is a compound is being made from simpler materials. This could be from elements or other compounds, but we're putting 2 things together to make a larger compound. So the simplified or generic version of this is A plus B goes to AB. When we think about this, I want you guys to think about math when we use our math variables. If we were in math class and wanted to use an X or a Y, it would say that it could be any number out there, any number, because it's a variable. This generic form of A plus B goes to AB is the exact same way. So, one example of this, we've talked a lot about salt. This is NaCl, so sodium Na plus chloride Cl2 goes into NaCl. So, if you guys have not seen these little brackets next to the compounds before, this is the phase it's under. So an S stands for solid, a G stands for gas. We also have liquid and this thing called aqueous, which we might get into a little bit later as we go through examples. But this is the basic synthesis reaction. So I have a video showing a synthesis reaction. I don't have time to do this in our lecture right now, but I have linked the video for you guys to pull up. So please pause this video and watch this one that is linked and then continue my lecture. Alright, so our next one is a decomposition reaction. So a decomposition reaction is when a compound is broken down into simpler compounds or elements. So it's the opposite of a synthesis reaction. So in a synthesis reaction we were doing A plus B goes to AB. Now we're taking AB and breaking it into 2 simpler elements or compounds. So for example, this is calcium carbonate, I believe. So we are taking calcium carbonate, which is a solid. It's actually a salt that is found in rocks, and we're going to break it into calcium oxide and CO2, which is carbon dioxide. So this is a gas that we've seen a lot, carbon dioxide. But anytime we have one larger compound breaking down into 2 simpler ones, it is a decomposition reaction. And another one that is interesting is hydrogen peroxide. This is aqueous. AQ means it is in water. So this H2O2 is very similar to water, but it is often used to be put on cuts. So H2O2, which is H plus, which is gas, and O2, which is gas as well. So I have a fun video for this one. This is elephant toothpaste, which I think you guys have seen videos of before, but always fun to watch another, and they explain a little bit of how this H2O2 gets decomposed and creates all these bubbles. By putting soap in with this decomposition reaction, we have soap with a aqueous solution, and as it reacts, it creates a lot of gas bubbles which are trapped by the soap. So, just an interesting way the chemistry works. The next one is a combustion reaction. This one is my favorite. So combustion reactions are very specific, very unique compared to the other ones. So it's a compound made of carbon and hydrogen which reacts with oxygen gas to produce carbon dioxide and water. So unlike our other ones where we've had, it could be any AB goes into A plus B, or we always are going to have some kind of carbon molecule with a carbon-hydrogen molecule, and it can be any number of them. We could have 10 carbons and 20 hydrogens, or 1 carbon and 4 hydrogens. And it's always reacting with oxygen to make CO2 and water. So one example of this is CH4, which is a gas, goes into reacts with oxygen to have CO2 plus H2O, and this L stands for liquid. So we have gases, or this should be a solid. Oh no, this is a gas, and a liquid. So it also creates some heat and light. So anytime we see a fire, this is the type of reaction that is going on. Also a good video about combustion and how it is used in rockets. So I hope you guys enjoy that one. This one gets a little bit more complicated than the first few. It is a single displacement reaction. So in a single displacement reaction, one element starts by itself and replaces another element in a compound. So for example, our A plus BC goes to AC plus B. Our A is going to displace or remove our B, kicking it off by itself. So our other example for this with real elements is if we have our solid iron going into an aqueous copper chloride solution, our Fe, our iron, is going to be mean and kick off our copper and take the chloride for itself. So this video is more of a lab video, but it has an interesting way of finding out and learning about the gases produced and kind of testing it that way with zinc and hydrogen chloride. So, and then our last one is a double displacement reaction. So we have the positive and negative ions in the two compounds switch places. So for example, we have AB plus CD goes to AD plus BC, and we can see it up here in our bubbles too. Our B and our C are just swapping places, so we're left with AD plus CB. Or sorry, our B is switching places with our D. So our A and C are going to change the same, or stay the same, while our B and D change. So for example, if we have I think this is a barium chloride plus a sodium sulfide with a barium sulfite and a salt. We'll create salt. So we're having this Ba change with the Na plus. The sodium. So our Ba is going to be moved into this molecule like here, and our sodium is going to come out to our Cl to make salt. So we have another good video to explain that. And then finally, I have made a table over everything that we just worked through. Our synthesis type, our reaction type, reaction type. We have synthesis, decomposition, combustion, single displacement, and double displacement. And then we have our generic forms of each one and an example for each. So this is a good tool, a good place to go back and quickly remember or learn or refer and use this to help you remember what double displacement looks like, single displacement, combustion, decomposition, and synthesis, especially as we start to do some worksheets with them. So I hope that all made sense. If you have any other questions, please let me know.